Good morning students. Today we are going to deal with Surface Chemistry Unit 5 and this is part 8. The first topic we start with is emulsions. What are emulsions? They are actually liquid-liquid colloidal systems in which both disperse phase and dispersion medium are liquids. Liquid-liquid colloidal systems means both disperse phase and dispersion medium are liquids. The common examples are milk and butter. Now we move on to the types of emulsions. First is oil in water type, where water acts as dispersion medium and oil is disperse phase. Example, milk, in which liquid fat is dispersed in water, and vanishing cream, which leaves no visible traces when rubbed on skin. Second type is water in oil type, where oil acts as dispersion medium and water is the disperse phase. Example, butter and cream. And here you can see the oil in water type emulsion and water in oil type emulsion. The yellow spots are oil and the blue color is for water. So you can see clearly the difference. Now you have to remember one thing, emulsions are usually not stable and they separate out into different layers on standing. So what happens? Small quantities of certain substances are added to emulsions during their preparation, and these substances are called as emulsifiers or emulsifying agents. So here you can see oil and water separated into layers, addition of emulsifier or emulsifying agents, and stabilization of the emulsion. Now you have to remember that emulsifying agents form interfacial film between the suspended particles and the medium. Now here we have some examples of emulsifying agents for oil in water type emulsions. Example, proteins, gums, natural and synthetic soaps. And emulsifying agents for water in oil type, heavy metal salts of fatty acids, long chain alcohols, lamp black. Lamp black is a fine light fluffy powder derived by collecting the soot from the burning oil. So after this, here you can see the oil in water type and water in oil type. After putting the stabilizer, that is the emulsifier, we get the uniform stable emulsion. Properties of emulsion: they can be diluted with any amount of dispersion medium. Droplets in emulsions are often negatively charged and can be precipitated by electrolytes. They exhibit Brownian moment, electrophoresis and Tyndall effect. Now we have a new term here, de-emulsification. The word is the opposite, the reverse of emulsion. So it is de-emulsification. It is the process of separation of emulsion into constituent liquids. And what are the methods we use for de-emulsification? Heating, freezing, centrifuging. And best example is cream separated from milk by centrifugation. Now you have to remember that colloids play a very significant role in nature and also in our daily life. And we are going to discuss some of them here, and mainly reasoning questions are asked from this part. And you have to remember that when you answer these questions, the key words should consist of colloids, coagulation, all these type of words which are related to colloids should come in your answer. So first point we are going to take in this is that sky appears blue. You have seen that sky appears blue to us. So why is it so? This is because of scattering of light by the colloidal dust particles. See, the word colloidal dust particles have come here. And why we are calling it as colloidal dust particles? Because here dust particles along with water is suspended in the air in colloidal form, and scattering of light takes place similar to that of the Tyndall effect, and that is why sky appears blue to us. Second, in winters you might have seen that the moisture of air condenses on the surface of dust particles, forming fine droplets which are of colloidal size. These droplets, being colloidal in nature, continue to float in air in the form of mist or fog. So you can see here the fog and the mist formation. The third, clouds are aerosols. Aerosols we have already taken up in the previous presentation. Clouds are aerosols having droplets of water suspended in air, and due to condensation these colloidal droplets of water grow bigger in size and they come down in form of rain. And sometimes rain occurs when two oppositely charged clouds meet. Now another important thing to be noted, it is possible to cause artificial rain which is known as cloud seeding by throwing electrified sand or spraying a soil carrying charge opposite to the one on the clouds from an aeroplane. So this is done, you can see here. Now you all know that blood is a colloid, and the styptic action means causing bleeding to stop. The styptic action of alum and ferric chloride is due to coagulation of blood to form a clot. Okay, so blood is a colloid and the clot is formed due to coagulation process by the action of alum or ferric chloride on it. If you rub alum or ferric chloride on a bleeding wound, coagulation will take place and clot will be formed and the bleeding will stop. So you may be asked a question that why does bleeding stop when alum or ferric chloride is applied on a bleeding wound? Then you have to give the answer that coagulation of blood takes place and clot is formed. Now the next point, milk, butter, ice creams, etc. are colloids. Many food items you can see, these are all colloids, you can see here. Now fertile soils are colloidal in nature, in which humus acts as a protective colloid. Protective colloid you have already seen, and on account of colloidal nature, soils absorb moisture and nourishing materials. So you can see clay, humus, etc. in the soil, which help in absorbing moisture and nourishing materials. Now you all might have heard about delta. Actually what happens, river water contains charged colloidal particles of clay, and as soon as the river comes in contact with the sea water, the electrolytes present in the sea water coagulates the colloidal clay. This results in deposition of clay at the point of contact of sea and river. Thus, the level of river bed rises. Now, you can see the river bed level goes on rising. As a result, the water adopts a different course. You can see the river water changes its course and a delta is formed. Delta is actually the heap formed which has shape similar to Greek letter delta. That is how it gets its name. Here also you can see the river water changing its course due to the formation of delta. Now next topic is application of colloids. Now under application of colloids, first one is electrical precipitation of smoke. Smoke is actually a colloidal solution of solid particles such as carbon, arsenic compounds, dust, etc. in air. And when this smoke comes out of the chimney, led through a chamber containing plate having opposite charge to that, the smoke particles get neutralized and they lose their charge and get precipitated and settle down on the floor of the chamber, and the precipitator is called as Cottrell precipitator. So you can see the smoke particles coming in contact with the plate, loses their charge and get precipitated and gets settled down. This precipitator is Cottrell precipitator. Now purification of drinking water. The water obtained from natural sources often contains suspended impurities. Alum is added to water to coagulate the suspended impurities. You might have seen this, when alum is added to muddy water, the mud settles down. The suspended impurities are settling down and you get the clear water which can be decanted off. Here you have the samples of alum. This is pure alum block which is used for coagulation and purifying of water. Now you have to remember medicines. Medicines are colloidal in nature. For example, argyrol is a silver sol used as an eye lotion. Colloidal antimony is used in treating kala azar. Colloidal gold is used in intramuscular injections. Another medicine is milk of magnesia, which is an emulsion. Milk of magnesia, which is an emulsion. Colloidal medicines are more effective. Why? Because they have large surface area and they are easily assimilated or absorbed. This you have to remember. Now next application is in tanning. You know, animal skin or hides are colloidal in nature. When a hide which is positively charged is soaked in tannin. Now tannin is an organic substance present in plant tissues. So when we soak hide in tannin, tannin contains negatively charged colloidal particles and hide has positively charged particles. So mutual coagulation takes place and this results in hardening of leather, and this process is termed as tanning. Instead of tannin, sometimes chromium salts are also used during the process of tanning. So you can see here the tanning of leather being done. Then the fifth application is cleansing action of soaps and detergents, which we have already taken. The sixth application is in photographic plates and films. Photographic plates and films are prepared by coating of an emulsion of light sensitive silver bromide in gelatin over glass plates or celluloid films. So this is an application of colloid. Now in rubber industry, you can see here the latex is collected from the rubber tree. So latex is the milky white sap of rubber trees found beneath the bark of mature rubber trees. And this latex is colloidal solution of rubber particles which are negatively charged. And with this latex, if coagulation is done, we'll get rubber, and this is the raw rubber sheets which are obtained on coagulation of the latex. Here latex is collected and coagulation of latex gives raw rubber which is beaten into sheets. Industrial products such as paints, inks, synthetic plastics, rubber, graphite, lubricants, cement, etc. are colloidal solutions.